SIL classification by SIL layer metric method. SIL layer metric is one of the qualitative methods for SIL determination which described by IEC standard and present in the Annex E of the IEC 61508 Part 5. The same methodology is detailed in ISA standard S84.01. Application of the safety instrumented system for the process industry, Annex A.3.1, and the same principle also presented in the IEC 61511-3. Before reviewing the present risk reduction, each process it should begin with the most fundamental element of the process design, such as process technology selection itself, the choice of the plant location, decision about the hazardous inventory. The careful selection of the process design and operating parameter is a key step in the design of the safe process. Unfortunately, even after the design philosophy has been applied, the potential hazards may still exist, and additional protection measures should be applied. This is a picture of the layer protection. It starts from the process, from the inside, and next layer is process design and BPCS, and alarm operator action, and ESD automatic action by SIS. Then active passive protection such as firefighting, and then plant emergency response, and the last layer is a community emergency response. What is the criteria of protection layer? A protection layer consists of a grouping of the equipment and or administrative control that function in concert with other protection layer to control or mitigate the process risks. That is the first criteria. Second criteria is a protection layer shall meet the following criteria. The first one, reduce the identified risk by at least a factor of 10. And second one, has the following important characteristic. Specificity. A protection layer is designed to prevent or mitigate the consequence of one potential hazardous event, so multiple causes may lead to the same hazardous event, and therefore multiple event scenario may initiate action by the same protection layer. Second one, independent. A protection layer is independent of other protection layer if it can be demonstrated that there is no potential for common cause or common mode failure with any other claimed protection layer. And third one, dependability. The protection layer can be called on to do what it was designed to do. And last one, auditability. A protection layer is designed to facilitate regular validation of the protective function. So, next one, protection layer. The following is an example general protection layer to control mitigate process risks that you may find in every day in the process. First one, IPL start with the die that can reduce the frequency of large consequences such as the spillage or tank overfill, tank rupture. Next IPL is the underground drainage system that also can reduce the frequency of large consequence. Or open vent. It can prevent the overpressure. Or fireproofing that can reduce the heat input and provide additional time for depressurizing or firefighting. And then brass walls bunker that also will reduce the frequency of large consequence of explosion. Next one is the relieving valve that can prevent the excessive specific overpressure, same as a lab unit. This is a common IPL that we can find in the petrochemical or factory. And then what is the following example which is not considered as a protection layer, such as the training and certification, procedure, testing and inspection, maintenance, community. You can see the IPL that related to the human is normally not considered as the IPL because it's related to the human factor. Next one, what's the relation between a hazard identification to SIL classification? The main input to SIL classification is the hazard analysis, which is used to identify the hazard potential process deviation and their cause, available engineering system, initial event and potential hazards event that may occur. This can be accomplished using the hazard study. And then what is the safety layer metric? Safety layer metric is the similar technique of the qualitative risk analysis in hazards. So after the hazard study has been performed, you can see the risk associated with the process shall be evaluated with the expertise of the plant personnel and other hazards and risk analysis specialists to identify potential hazard event and evaluate the likelihood, consequence, and impact. A similar approach can be used to develop the metric that identify the potential risk reduction by safety instrumented system or SIS protection layer. Such a risk metric is shown as per the picture, with safety target level has been embedded in the metric. The metric has writing from the severity and likelihood, same as the risk assessment. The left-hand side shows number of the protection layer. Start with the 3, 2, and 1. And the bottom shows the hazard event severity rating that can be classified into the minor, serious, and extension. And when it crosses with the hazard event likelihood, we can separate into low, medium, and high. And you can see in the crossing metric, it shows 1, 2, and 3. 1, 2, and 3 is mean the SIL level required, additional SIL level required for protection layer. What is the meaning of the hazard event likelihood? This is the example hazard event likelihood from the IEC standard. It can be classified into 3 levels: low, medium, and high. Low is mean event such as the multiple failure of diverse instruments or while multiple human error in the stress-free environment of spontaneous fail of a process vessel. The likelihood is very low. Mediums can be classified as an event such as a dual instrument valve failure or major release in loading unloading area, or high event such as the process leak, single instrument valve fail, or human error that result in small release of hazardous material. It can be classified as the high likelihood. And what is the criteria of the rating severity? This is a picture of the example classification of severity based on the IEC standard, starting from the extensives, means large-scale damage of the equipment, shutdown of the process for long time, catastrophe, consequent to the personnel and the environment. Serious damage to the equipment, shutdown of the process, serious injury to the personnel and environment. Minor damage to the equipment, no shutdown of the process, temporary injury to the personnel and damage to the environment. What is the mixing between the project risk metric for the safety layer metric? From above table is a rating guidance provided by IEC standard. However, the likelihood of occurrence of the hazard event and severity of the impact of the hazard event shall be developed based on brand-specific expertise and experience or company-specific data. So, to consistency with the risk metric in a hazard study, we can mix it up. As per the picture, I already combined the project risk metric with the safety layer metric. This is a combination of the risk metric and metric for safety layer metric. To starting with the safety layer metric, we have to study with the procedure. Procedure of the safety layer metric, starting with the identify on hazardous event of interest, hazard identification, which can be extracted from the pre-hazard study. Then we have to establish the hazard event scenario and utilize the hazard event likelihood, the severity rating of the hazard event using the project risk metric for the safety layer metric, and estimate the likelihood of the hazard event should be reduced by one step lower for every protection layer. It means likelihood of hazardous event of the hazard is different with the SIL classification. And third one, identify the existing protection layer to estimate the likelihood of the hazard event should be reduced by a factor of 10 for every protection layer. And last one, determine the SIL classification from the table safety layer metric. This is the way to conduct the safety layer metric. Thank you so much for watching my video, and let's see our next video. Bye bye.